Greetings, summer histology class. This is Dr. Ogilvie. I want to share some insights about the most recent quiz, the graded practice quiz, Module 1 Part A quiz, and Module 1 Part B quiz. First, I want to draw your attention to page 12 of the syllabus. Hopefully most of you realize by now that the graded practice quizzes are intended to help you learn, and they should be taken advantage of fairly early in your study period in each module. And you're given 3 chances to take that quiz, and we keep the highest score. And we give you full feedback after you've finished the last attempt, which is at least 1, 2, or 3 days before the definitive module quiz deadline appears. All the quizzes, including the graded practice quiz as well as module Part A and Part B quiz, are available at the very beginning of each module period and remain available until the module ends. You're given 2 attempts to take each of the module quizzes, and Part A, I encourage you to read this, but let me just point out it's a test in your ability to recall lecture and lab content involving the identification of cells, tissues, organs, and their components. And most of the specimens, if there is a specimen presented, which there will be, in Part A, will be from WebMic, but up to 25% may be captured from other sources. And some of these questions referring to specimens will require type-in answers. Now when you get to the midterm and the final, any specimen you're presented will require you type in the answer. And we give you a really long word list for the whole course that's available. And hopefully you found that list and have taken advantage of it and are looking it over. And you can have that available while you take the test. And so Part B are questions that are related to virtual slides that come from a virtual slide collection that we have. Some of them will be the very ones that you study in the BioLucid Lab collection, and others will not be. And these are designed to challenge you to do more than just memorize an image, but to apply some of the principles of the criteria of how to distinguish one entity in the course from another, or one entity from 4 or 5 logical, close related structures, cells, tissues, or organs. So please understand that when you get to Part B, it's going to require you not just to make a snap judgment, but to think. And as I proceed with this video, when I get to Part B, I'm going to try to demonstrate how you should be approaching these kinds of questions. So let's go to Part A now. So Part A consisted of about 35 questions, and many of them were just text questions. Like, for example, this first question. It says, choose any cell structure that would not be a part or contribute to the stroma of an organ. Well, the first thing you have to remember is that the stroma is the framework. It's like the walls of a house, separating the rooms into separate rooms. And it's composed of collagen, reticular fibers, elastic fibers. These are structural components that frame the delicate functional cells in an organ, and the functional cells are the parenchyma. So a mast cell is a functional cell, a parenchymal cell. A lymphocyte, the same thing, and a macrophage, the same thing. But a fibroblast, it contributes to the stroma of an organ, so therefore it makes collagen fibers and elastic fibers, and of course collagen fibers and reticular fibers. Now of course, some of you got this question incorrect, and so I just hope that helps point out some important things. And then if you did not do well on the mitosis and the cell cycle, be sure to go back and review that, because DNA replication does occur during the synthesis stage, not gap 1, 2, or mitosis or prophase. And then during which part of the cell cycle does the cell growth stop? Well, that's in mitosis. The cells increase in size until they're finally programmed to go prophase, metaphase, anaphase, and telophase, which are the steps in mitosis. And most of these questions, the class did pretty well, so I'm just going to scan down through these and not make much of a comment. But let's just pause on this one. 85% of the class answered this question correctly, where you have one kind of epithelium, stratified squamous non-keratinized. It lines the esophagus. But in a patient with gastric reflux disease, the acid from the stomach backing up can actually irritate that normal histological lining of the esophagus and transform it into simple columnar epithelium. And actually, that process can continue into cancer. The transformation from the stratified squamous non-keratinized to simple columnar is a condition called Barrett's esophagus. But Barrett's esophagus can then become cancerous. Well, that process of changing one type of epithelium to another in a place where it should be the first type that's normal, that's metaplasia. Meta is change, plasia is growth. Dysplasia is disorganized growth, neoplasia is new growth, and apoptosis is programmed cell death, and necrosis is a cell death by other means other than programmed cell death. For example, hypoxia. If there's not enough oxygen is being delivered to cells, then the cells may become necrotic. So macula adherens is spot. They're like spot welds between cells. So that's the correct answer. But hemodesmosomes, where 19% of the class chose, that's at the base of the epithelium, and that's really half of a desmosome, and it connects the basal cells of an epithelium to the basement membrane. Now let me just move down through these. If you spot a question here, I think you can still see questions you missed. And if this stimulates you to post on the discussion board, that would be great. Make sure you review the size relationship, like what was equal to 1 micrometer. Well, it's 1,000 nanometers. But 1/10 of a millimeter is 100 microns. This would have to go over to a couple decimal points to be a 1 micron. A lot of people did pretty well on that one, so I want to get to some of the images because I think that would be helpful. Again, if you spot something as I'm going down through here and you would like to post about that, please do. Okay, so 76% of the class got this answer correct, and the statement was this specimen is composed of 2 types of tissues. The cells whose nuclei are indicated by arrows are located in dense irregular connective tissue. Well, they are not, because you see the little round cells here, and most of those are lymphocytes. But if you see a cell with the elongated nucleus in here, that's most likely a fibroblast. But you see very few fibroblasts. Very few fibers, collagen fibers. So this is highly cellular, and it's very characteristic of loose connective tissue, not dense, either regular, which is like in tendons, or irregular, which are in capsules of organs. Okay, the next one, you're presented this image, and your cells whose nuclei are indicated by arrows synthesize and secrete antibodies. Well, hopefully you could see, if you look closely, and you can actually enlarge this by getting a closer look and see that it looks like a clock-faced nucleus, and that's very typical. Even these cells over here are the same. They're plasma cells, and those cells are plasma cells, and they produce antibodies. So that's true, and 80% of the class got that correct. Here's an image, lower left and higher right magnifications of tissue is shown. Which of the products are secreted by the cells whose nuclei are indicated by the arrows on the right? Well, that's collagen, and that's very typical. Elongated nuclei next to acidophilic or eosinophilic staining with hematoxin is very characteristic of collagen. Okay, now this is a specimen of dense irregular connective tissue. Now, if you're going to call something dense connective tissue, it's got to be dominant with fibers. And you just have little wisp of fibers here. And this is embryonic connective tissue. And these large cells are very similar to fibroblasts, but at this stage in the embryo, they're called mesenchymal cells. Okay? Here's the next one. Simple columnar epithelium covers a surface that borders the space labeled with the letter L. Okay. Here you see these cells. You see the nuclei. You can see them all pretty much at the same level. And the cells are longer than they are wide. So, and there's only one layer of nuclei, one layer of cells, so it's simple, one layer, and columnar because they're taller than or wide, so it's simple columnar epithelium. Well, the class did very well on that one. The morphology of these cells immediately surrounding the blue dots indicates they are serous glandular cells. Well, that's false because the blue dots are in the midst of glandular cells that are very lightly stained, and these are mucus cells, and they would be like mucus, the adjectives, M-U-C-O-U-S. There are mucus cells that produce mucus. The noun, M-U-C-U-S, mucus. Okay? So the other cells that show some granulars in them and a very solid staining are serous cells, and they produce protein, not the mucus. Okay, and this says the tissue that occupies most of this specimen is transitional epithelium. Okay, well that's false, and about 76% of the class got that correct. Well, first of all, it's many layers from here on up to the top, and the top layer of cells are flat. And so this is stratified squamous, non-keratinizing epithelium. Okay, and here this cell, here it says this cell type represented by those that are circled and those indicated by the arrow is. What is the cell type? Well, now this is an example where all these correct answers were accepted. Because when we have a type in answer, we try to think of all the possible answers that you could type in that would be correct. And you can see that we are pretty fair about that. And even if you, when we analyze these type in answers, we get to see what everybody puts in. So the TA for the course goes down through, and if he finds something that is correct, he makes it available to me, and then I put it in the key and regrade. 52% of the class got that correct. Okay, these structures indicated by arrows in one word describe the staining reaction of these structures. Okay, those are nuclei, and those are blue, and this is hematoxylin, so they're attracted to hematoxylin, and so they're basophilic. The hematoxylin is has a basic, instead of acidic, it's basic, and so therefore the dye attracts basic structure, so it's basophilic, and so it's the nucleic acids in here, and the ionization of the phosphate groups that is really complexing with the positive charged hematoxylin. 61% of the class got that correction, that question correct. And this said, what was removed during the processing to make the dominant cell type in this enlarged view appear empty? Well, this is adipose tissue, and it's the unilocular, the large lipid that occupies one single large lipid vacuole that occupies each cell, compared to the multilocular brown fat, in which there are many tiny vacuoles of lipid in one cell, and a lot of mitochondria, by the way. So what was taken out? Well, fat, lipids, lipid vacuole, lipid inclusion, anything that related to lipids we accepted. Okay, so identify the tissue enclosed within a dotted line. Well, now you have some fibers in here, but they're not very thick. And so when you have fibroblasts, you see the elongated nuclei in here. So we accepted areolar connective tissue, loose connective tissue proper, etc. And not many in the class got that correct. In preparing tissue for microscopy, cutting a paraffin embedded specimen with a microtome 50 microns in thickness is the ideal thickness to see detail. Well, the thinner you have it, the better, and certainly 50 microns is way too thick. It should be at least only 10 microns, and even below that. The thinner you get the specimen, the more detailed you can see. Okay, so I'm going to stop this video, and then the next video is going to review part B of the first module quiz.